If you gaze at the night sky, you might spot a tiny bluish-white speck of light. It looks like just another distant star, but it's actually the blinding glow of a colossal accretion disk swirling around a supermassive black hole. This object is so immense that it makes entire galaxies feel, well, insignificant. We're talking about a cosmic colossus that shatters our understanding of how things grow in the void. To understand its name, we have to look back at the records of the Tonantzintla Observatory. It was simply listed as entry 618 in the Tonantzintla catalog, a project led by Braulio Iriarte and Enrique Chavira. That's how we found TON 618. Today, we're going to venture toward an object that pushes the very boundaries of the vacuum and explores the sheer, oppressive scale of the darkness. Cast your eyes toward the northern sky, just below the handle of the Big Dipper. Right there, perched on the border between the constellations Cain's Venatici and Coma Berenices, sits TON 618. It isn't just a random point of light. It's the powerhouse core of a galaxy far, far away. Let's travel back to 1957 at the Tonantzintla Observatory in Mexico. Astronomers Braulio Iriarte and Enrique Chavira were scanning the heavens when they spotted something peculiar. At the time, it appeared to be a faint blue star. For over a decade, this belief persisted, with researchers convinced they were looking at a white dwarf. But then, 1970 brought a revelation. Radio surveys conducted that year stripped away the illusion that had fooled the scientific community for years. It's humbling to realize that the light reaching our telescopes today is an echo of a time before the Earth even existed. For years, that faint blue light remained a mystery, but spectroscopic studies eventually revealed that TON 618 isn't a star, but the heart of a distant galaxy powered by a black hole of impossible proportions. This is what astronomers call an active galactic nucleus. At its core, the engine is a supermassive void feeding on intensely hot gas and matter in a swirling accretion disk. This disk isn't just spinning, it's a violent, screaming carousel of matter being crushed by gravity. The friction and collisions within this disk generate temperatures of tens of thousands of degrees. It's a furnace of cosmic proportions. The accretion disk of TON 618 radiates across every wavelength, from radio waves and visible light to X-rays and gamma rays. It's not just bright, it's blinding. The energy output of TON 618 equals the combined light of 100 trillion suns. To be precise, it's 140 trillion times the luminosity of our own sun. If TON 618 were placed at the center of the Milky Way, it would be 23 times brighter than a full moon and would outshine every single star in our galaxy. The night sky would be stripped of its darkness, replaced by a second, terrifyingly bright sun that never sets. Now we enter the numbers, and this is where the logic of our own cosmic neighborhood begins to break. To grasp the scale of TON 618, we have to look at the heart of our own galaxy. At the center of the Milky Way, we have Sagittarius A star, a black hole with a mass of approximately 4 million solar masses. It's a monster by our standards, but compared to TON 618, it's practically a pebble. TON 618 is more than 16,000 times heavier than Sagittarius A. Consider the 2004 analysis by Ohad Shemer and his colleagues. By analyzing the width of the H-beta emission line in the Quasar spectrum, they estimated the mass of TON 618 at approximately 66 billion solar masses. If this figure is correct, we're talking about a single object more massive than every star in the Milky Way combined. Think about that. The total stellar mass of our entire galaxy is estimated at roughly 64 billion solar masses. It's almost impossible to wrap the mind around the idea of a single void outweighing an entire galaxy's worth of stars. Of course, there's a debate in the physics community. More recent measurements have revised this slightly downward, suggesting a mass between 60 and 66 billion, or even as low as 40.7 billion solar masses. Even if the lower estimate is correct, TON 618 still represents roughly 2/3 of the stellar mass of the Milky Way. It's a concentration of mass so extreme that it defies our very definition of what is possible in the universe. To understand the physical footprint of this monster, we have to look at the Schwarzschild radius, the point of no return. In physics, this radius scales linearly with mass. If you double the mass, you double the size of the void. For example, a black hole with the mass of one sun has a Schwarzschild radius of about 3 kilometers. Even Sagittarius A star is a titan with a radius of approximately 12 million kilometers, which is about 17% of Mercury's orbit. But TON 618 is in a league of its own. At 66 billion solar masses, the event horizon diameter is approximately 2,600 OU, or roughly 390 billion kilometers. To put that in perspective, that's 40 times the distance from our Sun to Neptune. If we dropped our entire solar system into it, the space from Mercury all the way to Pluto could fit inside TON 618's event horizon with room to spare. In fact, based on the higher mass estimate, TON 618 could swallow our entire solar system more than 40 times over without even filling its event horizon. Just consider the scale. A beam of light, the fastest thing in existence, would take weeks to cross from one side of TON 618's shadow to the other. Meanwhile, matter is being dragged inward, crossing the event horizon at speeds exceeding 7,000 kilometers per second. It's a void of such oppressive scale that our entire existence feels like a single grain of sand in a desert. It's truly dizzying. When you realize that Braulio, Iriarte, and Enrique Chavira initially assumed the object was a white dwarf, the scale of their mistake feels almost poetic. They were looking for a tiny, dense stellar remnant, a white dwarf, and thought they had found something small. Instead, they had stumbled upon the most massive void in the known universe. The numbers simply stopped making sense. How can a single object outweigh an entire galaxy's worth of stars? It's a psychological weight that leaves you feeling utterly insignificant, yet completely fascinated by the same void that fooled the very astronomers who first spotted it. What would happen if you actually drifted toward this void? As you approach the edge of TON 618, you would encounter the most extreme physics allowed by the universe. As you slide toward the event horizon, time begins to warp. In this distorted space, seconds near the horizon stretch into years for the rest of the universe. You would essentially be watching the entire future of eternity unfold and fast forward. But the light itself would change. Because of the crushing gravity, radiation near the event horizon is gravitationally redshifted, shifting bright light into a deep, bruised crimson. Everything you see would bleed into a dark red hue as you sink deeper into the gravity well. And then there's the center. At the heart of the black hole lies the singularity, where density becomes infinite and our current laws of physics simply break down. It's the ultimate dead end of space and time. If you reach that point, the universe's rulebook is thrown away. How can something have infinite density? We simply don't have the mathematics to describe it. This is where the physics becomes a problem. If black holes grow by eating stars and gas over time, TON 618 shouldn't exist this early in the cosmic timeline. Its massive scale suggests it grew at an extraordinary pace, or had an unusually massive origin, pushing the absolute limits of how fast matter can be crammed into a singularity. How does something get this heavy so quickly? Usually, supermassive black holes are thought to start from smaller cores of the first stars, or the direct collapse of primordial gas clouds, which allows them to skip the slow growth phase and start as giants. But even with a head start, the volume of material needed to reach billions of solar masses is staggering. We're looking at a growth spurt that defies standard expectations, forcing us to rethink the early universe's appetite. Makes you wonder if there are other monsters hiding in the dark, pushing against the absolute physical limit of how large a black hole can ever be. But science is rarely a settled matter, especially when we're peering 10.8 billion years into the past. Some astronomers believe the 66 billion figure is an overestimation. In a 2019 analysis by Guy and colleagues, the mass was revised downward to approximately 40.7 billion solar masses. That's still a cosmic titan, but it changes the scale of the monster. Why the discrepancy? Well, it comes down to how we measure these giants. The difference in mass estimates reflects the inherent uncertainty in deriving black hole masses from emission line widths in distant quasars. We aren't weighing them on a scale. We're analyzing the light signatures of gas swirling at incredible speeds. It's a precarious process, and the numbers shift as our models improve. Looking at TON 618, we aren't just seeing a void, but a physical limit. This monster pushes against the theoretical ceiling of black hole mass, which is estimated to be around 50 to 60 billion solar masses. Beyond this point, the physics of feeding changes. Accretion disks become so massive that they may actually begin forming stars, and those stars produce radiation that pushes back, disrupting further feeding. It's a cosmic stalemate. TON 618 exists at the very edge of what the universe allows a single object to grow, marking the boundary between a devourer and a star-forming factory. TON 618 is more than just a record breaker. It's a glimpse into the absolute limits of the cosmos, from its 140 trillion sun luminosity to an event horizon that could swallow our solar system 40 times over. It represents a scale of existence that challenges our intuition. We've traveled 10.8 billion years back in time to witness a void that outweighs the stars of our own galaxy, a place where light bleeds into crimson and time itself stretches toward infinity. And as we look at this titan, we have to remember that TON 618 is only one point in an expanding universe. If an object this massive can exist, it forces us to ask, is there something even larger still lurking in the depths of the dark? A monster that makes TON 618 look like a pebble